you may have never seen before. The symbol is this little open circle for f of g of x in these parentheses. Have you ever seen this before? It means you're putting one function into another function. You're not adding them together. You're like creating a new function. Like, you know, you compose music with putting new notes in. You're putting a new function inside. So if you have f of x and g of x as two separate functions, we know how to do f of 8, right? That's just function notation. Plug 8 in for x and see what you get. So if I just had to do f of 8, that's not composition. F of 8, I plug the 8 in right there for that x, and I just evaluate. What's 2 times 8 plus 9? So that would be 16 plus 9 would just be 25. So I just get an answer of 25. Could you try B and C the same way? You're just doing function notation. You're not doing anything after that. Just function notation. I'm just going to write my note up here. 2 times 2 plus 9. This would be 13, right? And then 7 minus 8 would just come out to be -1. So what is important is that we're only touching the right side of the equation. These just mean y equals. Don't plug anything in on the left. And you have to be mindful the function f versus the function g, right? The name of the function matters. Okay, so now f, right? 4 plus 9. I plugged 7 into the other function, and 7 minus 8 is -1. Okay, so now this looks different than what I just did. So I need to actually put the entire function g of x is x minus 8. See that I circled it? I'm plugging that into the f function where I see the x. So instead of plugging in the number 7, I'm plugging in the function x minus 8 where I see that x. So the way you write it is 2 times x, but it's now 2 times x minus 8 plus 9 is still there from that original function. So that's it. This is an expression. I could simplify it, right? How could I simplify the expression? Distribute the 2 and then combine like terms. So, right. So do you see how the g is inside the function? See how I circled this and drew an arrow to inside the function? On this next one, the f is inside the function. So this whole function is going to go this direction with the arrow. So whatever's inside, you draw an arrow and put it inside the other function. So this is 2x minus 16 plus 9 is really what? 2x. What's negative 16 plus 9? Negative 7. So the answer is 2x minus 7. I got a new function. I composed one function into the other function. So I didn't add them together. I literally put one into the other. So this way, you're taking the, maybe I'll do it with a different color. So this time I want to take this whole f of x, 2x plus 9, and I'm going to put it in for this x in the other function. So I'm going to take 2x plus 9 and plug it in right there to replace that x. So I'll have 2x plus 9 minus 8. 2x plus 9 gets plugged in, and then I still subtract off 8. So I get 2x plus 1 as my final answer. So two things to notice. Did these come out the same? No. So we're going to start doing this test. This is a test to see if those are inverse functions. If they both come out to be x here, you know they're inverses. But if you don't know how to do composition, you can't test if they're inverses. We're going to learn about inverses tomorrow. All right, let's do it again. So you can go ahead and try A, B, and C on your own. So find f of 8, g of 8, and g of 0. And then we can do the composition together in just 1 minute. stuff like everyone else does. Did you finish those 3 questions? All right, let's see what we got. So f of 8, so I would do 1/2 times 8, which would be 4, minus 8 is -4. Is that what you got for the first one? 4 minus 8 is -4. Okay, so then g of 8 turns into 16 plus 16, right? So 32. Did you get that? And then g of 0 would just be 16 because this goes away and I would just have 16 left. All right, so let's do this in the right order. G is inside the function. So I take the g, I'm going to put it where x is sitting in that first function. So I would take the 1/2, that's going to still be there. And then inside the parentheses, I'm going to have all this stuff, 2x plus 16. And then I go back up, I have to also subtract off 8. So see what happens on that problem when you distribute the 1/2. See how that cancels here, you just get x. And when you distribute the 1/2 here, you get 8. And then guess what? You're subtracting 8. So everything cancels each other out. So you get left with x. You get x plus 8 minus 8 leaves you with just x. So these will be inverse functions of each other if it also works out in this direction. Now I have to try g of f. And this is difficult algebra. That's why Algebra 2 CP probably skipped it, because in Algebra 2, you're learning composition just for the sake of doing it. But in pre-calculus, if we're going to study inverses, we have to be able to do this to prove that they canceled everything out. Oh, good. So maybe you were introduced to it. So let's see. I take the f of x function, and I'm going to bring it over here, right? So I'm going to have the 2 still there. And then in place of x, I'm going to write this guy, 1/2 x minus 8. And then I'm going to leave this plus 16. So this is the g function, right? 2 times x plus 16. 2 times x plus 16, I just did substitution. So when you distribute, see how this just gives you x, because it's 2 times 1/2. 2 times -8 is -16, and you're adding 16. So the same thing happens, you just get x. We're going to learn tomorrow that that means that these are inverse functions of each other. Okay, I'd like you to try 3 and 4. See if you can figure out how to compose them. It may be challenging on 3, C, and D because you're square rooting, but at least set them up. I can help you. Yep, so you try 3 and 4. So, quiz question number 1 next Tuesday might be just like this. F of x and g of x, do a couple problems. So this would be like, quiz question number 1, skill number 1 is, can you compose functions? So we're practicing it through homework and review. Yeah, so this is the -16 from here. And then this doesn't get distributed, so this is just a plus 16, so they're opposite. So they cancel. Yep. Yes, because you're squaring that negative. See where I put your box. Can you do it? No. Oh, no. Are you just putting in an angle over? Yes. So there will be no solution. You can't take this through all the negative. I didn't give it back to you or something. Let me see. Oh, yeah. Maddie, were you also not here on, what was our last day, Friday? Yeah, you weren't here either, right? Okay. You can't square root a negative number. You can square it. This one has a line. Like on the edge. Okay, I want to go over those two. So take one more minute. So you got +4 for 3A, and you got no solution, right, for 3B. Sound good? So let's see. If I take K and plug it in and square it, aren't I taking the square root of X and squaring it? So those would undo each other, and you would just have X, right? I'm plugging a square root into a perfect square. So I'm square rooting and squaring it. So it just pops out as just X. And then if I do in the other direction, I'm taking the square root of X squared. So doesn't that also undo each other and leave me with just an X? So we're going to find out that that is a special relationship. They're inverses of each other. All right, then f of 8 would be what? 16 plus 8 came out to be 24. Is that right? G of 8, 1/2 times 8 is 4, minus 4 gives you 0. Did you get that? Let's see, G of f. So I'm going to take 1/2 times all that stuff and subtract 4. It looks like they're inverses, right? X plus 4 minus 4 gives me X. Oh, is this the same function from up above? Oh, no, it's totally different, right? All right, G into F, I take 2 times 1/2 X minus 4 and add 8. So I still get X minus 8 plus 8. So I still get X. So just being comfortable plugging a function into the other function is the idea of composition. Does that kind of make sense? So